So we've done, this whole chapter has been about linear systems, all right, systems of equations. But we've only had how many variables so far? 2 variables, all right? So if you have 2 variables, you have what? 2 equations. Well, you got 2 answers, that's true, but you got 2 equations, all right? So this time, we're doing systems of equations with how many? 3 variables this time. All right, so we are just going to jump right to an example. In my notes, I put skip example 1. Not really sure why, but we're skipping it. So we're going to example 2. And let's just teach this from the example. It's the same idea, it's just a little bit more involved, that's all. So the basic premise of doing these problems is the same. And you don't have to do it a certain way. You don't have to do it by elimination. You don't have to do it by substitution. We're just going to look at it and decide which method we think is the best. And we'll do it that way. All right, here we go. So we're not just solving for x and y this time. We're solving for x, y, and what? And z. So what we're going to do is we're not going to solve all 3 of them all at the same time. All right? We're going to break them up. We're going to do 2 of them, then we're going to do another 2, and then we'll get an equation for both of those, and then we'll do another 2. So it's kind of like we're doing 3 of them since we got 3 variables. All right, so let's take a look at these and see which ones we want to group together. It doesn't always have to be the first one and the second one, all right? We want to group them together. So let's just take a look and see which ones are like tailor-made for us. Which ones are made for us to put together. Yeah, I would say the first one and the second one, right? Why? Why did I pick the first and the second one? Because the y's cancel out. That's right. So if I did elimination, right, on these, the y's would cancel out. I'd be left with an x and a z. And then you could do the second and the third one as well, couldn't you? Do the second and the third one. The y's would cancel out, and you'd be left with another x and z. And then you put those 2 together, right? And then you decide whether you want to use substitution or elimination, and then go from there. Does that make any sense? All right, so when you're looking at it, I mean, this is the first example, well, the second example, but the first one of these types that they give you. It's going to be the easiest one. It's not always going to be this easy, but on this one, that's how I would definitely do it. You could start off with the second and the third one if you wanted. I mean, technically, you could start with the first one and the third one, right? But then you'd have to make one negative. But this is it's just perfectly made for you to do these 2 together. So if I do those 2 together, I'll tell you what I'm going to do. I'll cheat a little bit so I don't have to rewrite it all, okay? So I just took the first 2 and I put them next to each other. So I'm going to add them up. I don't have to multiply anything I don't have to multiply the top or bottom by anything because the y's already add up to 0, all right? So I'm just going to add everything up. So 1x plus 3x is 4x. This cancels out. Negative 2z plus z is negative z. And then negative 9 plus 13 is 4. Everybody with me? I'm going to put it in a box for safekeeping, and I'll come back to it in a minute. Okay? Everybody okay? I'm not putting it in a box because it's the answer, just putting it there so I remember which one to go back to, because you're going to have a lot of stuff all over the place. I like to keep things nice and neat and organized, so I'll put that in a little box. Now, what am I going to do? I did the first and the second one. What do you think I'm going to do now? Let's get rid of this one. Let's get rid of this. Yeah, we're going to do the second and the third one. We'll do those and do basically the same thing. Just rewrite it. And yeah, we'll just put it right here. And again, they made this. They rigged this thing for us to do very, very easily. Does everybody see that? Yeah. It's not always going to be like this, but the first one is. So now let's do these. So let's add up all the columns. Again, the y's will add up to 0. They'll cancel out. So right here I get 5x Right here, the y's added up to 0. This is going to give me a 5z. And this is going to give me, what's that, 30? You know what the first thing popped in my head on this? I would divide everything by 5 just to make things a little bit easier for me. Would you agree? Yeah, so let's do that. You can do that in your head. If I divide everything by 5 here, what do I get? X plus z equals what? 6. You don't have to do that, but I think it just makes things a little bit easier for us. Did everybody see that? It's not always going to happen, all right? You're not always going to be able to do that, but in that particular situation, I saw it. I'm like, oh yeah, let's get rid of the 5. It just makes things a little easier. So now, look at the two things in the boxes. So now I'm going to put those on top of each other, and then I'm going to try to solve for either x or z. Everybody good? All right. So it's the same thing as we've done before. It's just a little bit more involved. That's it. So I'll write it down this time. I won't be lazy. So 4x minus z is equal to 4x plus z equals 6. Wow, they rigged this thing too, didn't they? Again, I'm warning you, it's not always going to be this easy. They made this just about as easy as they could, just to kind of get you into the flow of things, you know what I mean? So now, let's do that. Look, the z's cancel out for sure. Everybody sees that, right? All right, so let's add up all the columns. 4x plus x is 5x. This is going to add up to 0. What's this going to give you? 10. Oh, that's easy. Divide both sides by 5. X is 2. So that's one of my answers, okay? Tell you what, I'll circle it, but I'm not really going to circle the answer. I'm getting 3 answers, so I'm not going to have an ordered pair for my answer. What am I going to have? An ordered triple, that's right. Have we talked about ordered triples before? I think I thought we did. Exactly. I'm trying to solve for all the variables, x, y, and z. Because those x, y, and z's will work for the first one, they'll work for the second, they'll work for the third. Okay? And you got to find the right ones. Now, once we get one of them, the rest are usually pretty easy to find. So which one would you use? You can use anything with it that has an x in it, but you could use this one. Now, I wouldn't use the original one. Why not? Because I still have a y and a z that I don't know, right? So I don't want to plug it into there. Plug it into one of the equations where I only have 2 variables, and one of them is an x. I could put them into this. I think this would be the easiest one, right? You could put it into this. It'd be fine. It would work. But I think this would be a little bit easier. So let's put a 2 in for the x. So 2 plus z equals 6. Subtract 2 from both sides. What is z? It's 4. So that's one of my other answers. Now I got 2 variables. Now I can put into one of the equations with a y in it. It doesn't matter which one. You could pick any of those 3. It doesn't make any difference. What do you think might be the easiest one? I don't know if there is an easiest one. The first one, I'd probably put it in the first one, yeah. Because I got an x and a y by itself. Even though I got a negative here, that's no big deal. So let's put it into the first one. So, are you okay if I just plug the numbers in and don't write down the original one? So I'm plugging it into this. So it's x, which is what? 2, plus y, which I don't know, so I'll just put a y, minus 2 times z. Well, I found z already. It's 4, so it's 2 times 4, negative 2 times 4, equals negative 9. And now it's just one equation, one variable, and I can solve for y. So I'm not going to do too much in my head. I'll just write down all the steps. This is going to be minus 8. Everybody see that? Negative 2 times 4 equals negative 9. Add like terms. 2 minus 8 is negative 6 plus y equals negative 9. Add a 6 to both sides. Add a 6. So what is y? Negative 3. But I don't want to write my answer like this, okay? I almost hesitated circling them. I just did it so I could see them easily, all right? So I want to write my answer as a thing called an ordered triple, right? So x goes first, then y, then z. So what is x? 2. What is y? Negative 3. What is z? Positive 4. And that right there, I will circle that one. That's my answer. And that's how you should write your answer. Don't write them separately like this. Okay, write it as an ordered triple. XYZ, yep. Everybody got it? So an ordered triple is XYZ. An ordered pair is just X then Y. Say that again?
Ordered triple, you go in alphabetical.
Yes. Well, yeah. Yep.
So if they give us like the G, for example, then
They won't. They'll just give you X, Y, and Z's. So again, not that difficult. You just got to keep everything straight. Again, they rigged this thing for you, didn't they? Because you got these things that cancel out. The next one, a little bit more involved. All right, so that just is, we're just kind of getting warmed up. Jocelyn. Yes. Right, it's what I just said. This one they rigged for you. They made this as easy as they could. It's not always going to be like that, okay? Like this next one. Yeah. Well, this next one's doesn't come out with fractions. Most of the time in a high school math book, they don't make things come out to fractions, but in real life situations, yeah, almost everything comes out to a fraction or a decimal. Hardly anything comes out nice and perfect and even. You know what I mean? So, but they're just trying to teach you the concept here. And they just put nice, easy numbers in just to teach the concept. But yeah, in real life, for sure, fractions and decimals are everywhere. There's way more times, like if somebody was going to build something, there's way more times it's going to come out to 3 feet, 7 inches, or 7 and 3/16 inches. You know what I mean? It's rarely always going to come out to this is 3 feet, this is 4 feet, this is 5 feet, that kind of thing. So that's how it works. All right, here's another one. Example 3. Now this one's a little different. We're still using 3 variables, but not all 3 variables are going to be in every single equation. All right, so this is a little bit different. 3y minus 2z equals negative 10, and then 4x plus 5z is equal to 56. All right. So this is a little different, but there's still 3 variables. So how many equations do we need if you have 3 variables? You need how many? 3 equations, right? And we got them. There's the 3. Now, not all of them, actually none of them has 3 variables in it, right? This has x and y. This has y and z. This has x and z. All right, so you got to figure out a way to work it out. You could do a couple things. Like right here, you can't, I don't know, maybe on the first one and the second one, you could maybe multiply that by a -3, so the -3y and the 3y cancel out. So you could do elimination if you wanted to begin with. I wouldn't, because of this equation right here. They make this equation kind of a little bit easier for you, because x is already, it doesn't have a coefficient, and y doesn't have a coefficient. So what I did when I did this, I took this one and I just got x by itself. So if I get x by itself, what did it have to do with this? Subtract a y from both sides. Would you agree? So 6 minus y. Now what can we do? I kind of have x by itself. Not kind of. I do have x by itself. So what can I do with this? I can plug that in. Where? Yeah, for x anywhere else, okay? So like the second equation doesn't have an x, so I can't plug it in. Now I could have done this. I could have solved for y, couldn't I? And then take whatever y is equal to and plug it in for this. Either way is fine. Doesn't make any difference. This is just how I decided to do it. So x is equal to 6 minus y, so what I'm going to do is come down here to this third equation and substitute, right, replace that x with a 6 minus y. So let's do that. It's 4 times x, which is 6 minus y, and then just write the rest of it down. Plus 5z equals 56. Let's simplify this as much as I can and then figure out what we're going to do after that. So let's distribute the 4. 4 times 6 is 24. Put the minus. 4 times y is 4y plus 5z equals 56. We're not quite done yet. Get rid of the 24. Subtract 24. And I get negative 4y plus 5z equals, what's that, 32? Yeah. Can I do anything else with this? No, not really. So I'm going to put it in a box. Everybody okay in there? That was just simple substitution, right? I got x by itself, plugged it in. I showed every little step. You may be at a point now where you don't have to show every little step. You might be able to do some of this in your head a little bit. It's fine, but I showed every step. Now, this has what in it? It's got a y and a z. Let's go back to the original 3. So which one do you think? Now, if you wanted to, you could do this. You got a couple options. You could take that first one, but instead of solving for x, you could solve for y. All right, so y would be what? 6 minus x. And then you could put it in for this. Everybody see that? And then get z by itself. Or this has a y and a z. What else has a y and a z? The second one right there. You could put those on top of each other and then do elimination. That might be a little more work than I want to do. I think maybe taking that first one, getting y by itself, and then substituting it in, that could be the best way. I didn't do that in my notes. You know what I did in my notes? I took this second one and this one, put them together, and I did elimination and solved. All right? So that's how I decided to do it. But now I'm looking at it, and I'm thinking a little different. You want to do it that way? You want to solve for y, or you want to put these on top of each other and then eliminate? Solve for y, it might be a little easier. All right, so let's solve for y. So if I solve for y on that first one, subtract the x from both sides, so it's 6 minus x. Then I'm going to take that and plug it in. I'll go all the way around here. Boom. Plug it in for that y right there. And then I can get z by itself. Oh, actually, hold on. What am I doing? No, I don't want to do that. Yeah, I definitely don't want to do that. My bad. Because I'm going to have to do elimination after that anyway, and that was just a wasted step. Let's do it. No wonder I did that in my notes. Okay? So let's take this one. The two that are in boxes, let's take both of those, put them on top of each other, because I don't know what I was thinking. Put it in here because I'd have an x and a z, and then I'd have to take that one and the new one and put them together. Again, that would just be a wasted step. You could do it. It would work. It's not efficient, though. Let's take both of these. So it's 3y minus 2z equals negative 10, and negative 4y plus 5z equals 32. All right, took those two in the boxes, just put them on top of each other. Everybody see that? Now, nothing eliminates really easy like on that first example. Remember the y's, they canceled out super easy. Now we're going to have to make this so that they cancel out. But we've done this before. This is not anything new. Right? We've done this before when we had two equations and two variables. What do you want to get rid of? You want to get rid of the y's, or do you want to get rid of the z's? Tell you the truth, I don't think one is any easier than the other. Get rid of what? The z's? Okay. So if I get rid of the z's, what am I going to have to make them in order to add them up to 0 for them to cancel out? I'm going to make them a 10, don't I? So how do I make this a 10? Multiply it by 5. And then multiply the other side by 5. I got to make this thing a 10. How do I make that a 10? Multiply it by 2. And multiply this by 2. Right? We've done that before, correct? Correct? Yeah. Okay. Just making sure you're with me. Let's multiply everything by 5 right here. What do we get? 15y minus 5 times 2z, which is 10z. And then this is negative 50. What do we get here? Negative 8y plus 10z. And this is why we did that whole thing. This is why we multiplied by 5 and then by 2, so that these two would be the same and we can cancel them out. Agreed? Equals what? 64? Now I can do the elimination. Now I can add up all the things. 15y minus 8y, what's that? 7y. This adds up to 0. And this is what? 14? Positive. Divide both sides by 7. What is y? 2. Once you get the first one, it's like dominoes. I've said that before, haven't I? Yeah, it's kind of like, you know what dominoes are, right? Not playing the game, actually, but when you stand them on end and you knock one over and it just boom, 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 boom. So once you get one, the rest are not that bad. So you could put it into here. Look, I wrote this down earlier, didn't I? Let's use it now. So y is equal to 6. I'm sorry. Let's do this one right here. Sorry. X equals 6 minus y. I mean, you could have put it in here and solved for x. It would have still worked. This one's a little nicer. So x equals what? 6 minus y. 6 minus what? 2. So x is 4. All right, so you got 2, you got 4. Now we got to find a z. Put it anywhere that you see a z. It doesn't make any difference. This is in a box. Let's just put it in there. Is that all right? So negative 4 times y. So that's negative 4 times 2, because we figured out that y was 2, plus 5 times z, which we don't know. So I'll put z equals 32. And now we just do a little bit of math, solve for z, and we got our 3. We got our x, y, and our z's. So this is going to be negative 8 plus 5z equals 32. And then add an 8 to both sides. So 5z equals 40. Divide both sides by 5. Z is 8. But we don't leave it like that. Okay, it's too scattered, right? Makes my brain hurt when I'm trying to find your answers and they're all over the place. So write them real nice and neat as an ordered what? Triple. Okay, and we put it in alphabetical order. We put it X, Y, Z. So we go 4, then we go 2, and we go 8. And that right there can be circled, and that's our answer. I think that's it. Or is there any other examples? 3-6. Let me check the book. Because normally I put the homework assignment after my notes, and I didn't. So I'm thinking, well, maybe. Yeah, that's all I wanted you to do. All right. So didn't I split this up into an A and a B? What did I say? Is anybody? I got to go over to my notebook and see. Let's see. What did I give you to do? Should have put it in my notes. There we go. 10 to 17. 10 to 17. I'll write that up here. So numbers 10 to 17. We're going to call this section 36A. What page did I say that was? I don't remember. 137. There you go. All right, so that's for tonight, and then tomorrow in class, I'm just going to give you the second half of this just to work on in class. And we'll review for the quiz on Wednesday, take the quiz on Thursday, and Friday, maybe you'll watch me walking through the woods or something. I don't know. Okay. All right, everybody good? All right.